And here we go. Hey, this is Charlie Thompson, and I know that there's already one too long didn't read for Lab 2, so I'm going to see how fast and efficiently I can get through this. So, Lab 2, we're talking about seasonality. We're talking about changes in day length, changes in the length of a day. And an important thing to keep in mind is the speed of seasonal change. So the two things that change with day length are the two things that change with the seasons are the angle of the sun, we'll get to that next week, and the length of the day. In winter, the days are shorter. In summer, the days are longer. And the rate of change of day lengths changes with the time of year and with the latitude that you're at. So with latitude is super duper duper important. It is responsible for 95% of everything in physical geography. Latitude controls average temperature. The tropics at the equator are hot. The poles are cold. Latitude controls temperature range. That's the difference between summer temperatures and winter temperatures. And at the equator, every day is pretty much like every other day. At the poles, in fact, the farther away from the equator you get, the larger the difference between the summertime high and the wintertime low. Latitude controls rainfall. The equator is wet. The tropics, right around 23 to 30 degrees, are dry. The mid-latitudes where we live are wet, and the poles are dry. Latitude controls seasonality. So at the equator, there's almost no change in day length or temperature throughout the year. I'll say that again because it's important and it's going to come up in the lab. At the equator, every day is pretty much a 12-hour day with pretty much the same temperature. In fact, the difference between summer and winter is so small that geographers often say night is the winter of the tropics, because the difference between noon or 4 o'clock in the afternoon when it's hottest and just after dawn when it's coldest, that difference is bigger. The daily temperature swings are bigger than any difference between summer and winter. In fact, those differences can be just a few degrees. At the equator, also in terms of day length, they have 12-hour days all year long. So every day is pretty much like every other day in terms of temperature, in terms of the angle of the sun, in terms of the length of the day. Above the Arctic Circle and Antarctic Circle, so now we're really far away from the equator, they have 24 hours of light in summer and 24 hours of night in winter. So there's 24 hours difference between the day length in the summer and the winter if you're above the Arctic Circle or below the Antarctic Circle. At the equator, every day is 12 hours. So the time of year, also, I think this is super interesting because Earth's orbit around the sun isn't a perfect circle, that the day length changes super fast at the time of the equinoxes. The equinoxes are the spring and fall equinox, March 21st, September 21st. Those are important dates. But around the time of the equinoxes, the day length is changing super fast. Like we're gaining or losing. Right now we're losing almost 2.5 minutes every day. So every week you're potentially losing, right now because it's fall, you're potentially losing 15 minutes a week. So that's like an hour over the month of September. Over the month of September, the day length is changing for Sacramento by almost an hour. However, at the time of the solstices, so the summer solstice on June 21st and the winter solstice on December 21st, there is no change in day length. There's no change in the angle of the sun. In fact, the word solstice means that the sun has stopped, and what that means is the change in day length and the change in the angle of the sun, there really isn't any right around the time of the summer and winter solstices. So I thought I'd include some maps. A picture's worth 1,000 words. So if you're above the Arctic Circle in the summertime, you have 24 hours of daylight, and the farther or the closer to the equator you get, you can see the closer to 12-hour day. So in the summer solstice, on the summer solstice, we have about a 14 and a half, 15-hour day on the summer solstice in Sacramento. If you have ever been at higher latitudes, like up in Seattle or Paris or Amsterdam in the summertime, they have a 16, 17-hour day. If you're going to get up to the latitude of like Sweden, for example, or Norway, like in the movie Midsummer, you're having an 18 and a half hour day. So again, by the equator on the summer solstice, a 12-hour day. Where we're having like a 14.5-hour day or so. And then above the Arctic Circle, they're having 24-hour long days, which means then below the Antarctic Circle, so in that's a tongue twister, in Antarctica, they're having 24 hours of darkness. But the equator, still a 12-hour day. Hours of daylight on the winter solstice. So the closer you get towards the equator, the closer to a 12-hour day you're getting. We have around a 9.5-hour day on the winter solstice, so our shortest day. The shortest day above the Arctic Circle, it's 0. There is no sun, no sunrise. In fact, the sun sets sometime in September, October, and comes up sometime in February or March. The difference in day length. So again, the closer to the equator, the smaller the difference. If this extended down to the equator, it would be around 0. And then above the Arctic Circle, 24 hours difference between winter and summer solstice. Hours of daylight lost between fall and winter. So just over 3 months, they're losing 12 hours, right? Because on the fall equinox, everybody in the world has a 12-hour day. And then on the winter solstice, they have 0. So they're going from 12 to 0. We have a 2 to 3 hour difference from fall to winter. And then if you were at the equator, there'd be 0. Every day is 12 hours long. Hours of daylight lost during September. So we're losing, like I said, hour and a half of daylight. The bigger or the closer to the equator, the less difference there is in the seasons. And the farther away from the equator, the closer to the poles, the bigger the difference in seasons. So during September, if you're up above the Arctic Circle, you're losing 4 to 5 hours of daylight just during September. So hopefully these are beginning to add up and you're getting the idea that day length changes are most dramatic at high latitude, and close to the equator there's virtually no change in day length. Minutes of daylight lost on the fall equinox. So this is just one day. And like I said, on the fall equinox, we're losing about 2.5 minutes. Every day they're losing 10 minutes. That's, in 6 days, that's an hour. If you're losing 10 minutes every single day. And then the closer you get to the equator, the smaller the amount of change. Oh, and I really like this one. Days with 24 hours. Civil twilight means that the sun is down, but you can still see stuff. So that's one of the there's civil twilight, there's naval twilight, and then there's astronomical twilight. And the definitions are the degrees below the horizon of the sun and what you can see. I think civil twilight, that would be like up to half an hour after sunset during civil twilight. I think in California, you don't need to have your lights on. It's still light enough that you can drive around without headlights. Nautical twilight, there's less visibility, and then astronomical twilight, it's almost dark. So this means that this is days with 24 hours of civil twilight. So if you're in Anchorage, you're getting 0 to 30 days. If you're in Fairbanks, you have 2 to 3 months where the sun doesn't set. So Fairbanks and in Nome, you have 2 to 3 months. So the sun would come up, like I was saying, and then every day the sun would just orbit in the sky, circles, and then set a couple months later. And that's it for the Lab 2 Too Long Didn't Read number 2 video. I hope it's helpful. I hope it gives you some insight into seasonal change. I hope you have a great week.